Okay, so who's seen that movie where this little kid says, "I see dead people"? Who's seen that? What's that movie? Yeah, The Sixth Sense. Thank you. So in this movie, this little kid has this creepy supernatural sixth sense for detecting dead people in the world around him. Now, I don't have this sixth sense. I have a different sixth sense. I have a sixth sense for detecting bad charts. And I see bad charts everywhere. I see them in annual reports. I see them in business dashboards. I've even seen a few at this very conference, right? So my goal in this 50-minute session is to start to give you all that sixth sense, and I'm sure many of you already have it. There's a lot of experts here. But for those who are experts, I hope to be able to fine-tune it just a little bit. So let's get into it. When it comes to telling a great story with data and producing beautiful charts, there's really 4 keys that I've broken it down to. The first key is the audience. We have to figure out who our audience is and what they need to know. This is step 0. Before I go selecting my charts, selecting color schemes, fonts, and all of that, the very first thing I do is figure out who is my audience and what is the big takeaway for them. Once I've knuckled down who my audience is, that will actually guide every single design decision that I make in the data storytelling process. And every design decision I make is not aiming at making things better for me. I'm aiming to make things more understandable and easy for my audience. So that's the first step. The second key to data storytelling is the data. So we have to get hold of the right data to inform our audience of what they need to know. And once we've done that, which is often easier said than done, once we've done that, then we've got to choose the right metrics to inform our audience of what they need to know. And this is actually an area where a lot of data scientists actually go wrong. Okay, a lot of data scientists are obviously highly technical people. And as data scientists, we're very comfortable not just with metrics like the average and the median and the mode, but we're also comfortable with the standard deviation and skewness and kurtosis and many more complicated metrics. And sometimes we have to say, okay, I'm going to put those metrics to the side so that my audience can actually understand what I'm talking about. So there's been situations where I will use a range instead of the standard deviation if I'm trying to communicate variation, right? So we want to choose metrics that our audience understands. Now, the next step, once we know who our audience is and the data we're going to use and the metrics we're going to use, the next step is to communicate it in some way using either tables or charts. And many people jump the gun and go for charts when perhaps a table may outperform a chart. Right, so we have to know when is a chart or a table appropriate. If we've decided to go with a chart, then we need some sort of methodology for chart selection. And many people don't have a methodology for chart selection. They just kind of choose whatever they think might be a good display of the data. But the good news is that psychologists and statisticians have done all sorts of interesting research in this area. And they've conducted empirical research into how humans perceive lengths, coordinates, and areas. And what we're going to do in this session is draw on some of that research to inform us of what chart is right for a given data type. Now, if the science tells us that, for example, a bar chart is the right chart to use, then we need to know the best practices for a bar chart. Where should the y-axis begin and end? How thick should the gaps between the bars be? How should we label it, etc. Right, so we'll talk about some of those. Now, I will admit that most of our clients, and I work for a company called DataSeer. We train clients all around the world in data visualization skills. And I'll admit that most of our clients do satisfy these first 3 keys generally well in their business dashboards, in their PowerPoint decks, in their reports. What I don't see done well is weaving it all together into a cohesive narrative. Like it or not, PowerPoint is probably the most common media that is used to tell stories in the business setting. I have a colleague who says power corrupts, and PowerPoint corrupts absolutely. But whether we like it or not, that is often the media that we use. And I see a lot of PowerPoint decks that are really just a series of facts. Each slide is just a new fact. And what we want to do is weave it all together into a cohesive story. So these are the 4 keys to data storytelling that we'll be covering in this session. Let's get into it. And I'm going to start with the audience, the most important key. This is a terrible graph. I give it a D- if I had to give it a grade. What we're going to do is make over this chart together using good data storytelling. Let's actually increase the font sizes because those at the back probably can't see anything, but do note that these font sizes are the default that Excel and PowerPoint chose. So anyway, let's increase those. Now, what I have here is Airbnb and hotels bookings data. The data comes from a friend of mine who's a lot wealthier than I am, and my friend owns a number of Airbnb properties and a number of hotel properties. And my friend sent me this data and said, can you tell me what's going on in my portfolio? Now, the very first thing I want to do before I talk about chart selection or color or getting rid of Calibri, the very first thing I want to do is figure out what is the big takeaway for my friend. Any ideas what is one of the interesting stories here? Anyone want to shout it out? Yep. Yeah, in summary, that's it. Airbnb is doing better than hotels. And just to add some restrictions to the study, my friend did hold his marketing budget constant throughout the entire time period and didn't add or subtract any Airbnb properties or hotel properties during this time period. So I totally agree. Airbnb is doing better than hotels. So it's at this point where, as a data storyteller, you've got to decide, what is my mandate in the organization? Is it my job just to tell the story? Or is it my job to perhaps recommend strategy recommendations? So moving forward to strategy, we might say, our recommendation is that you liquidate part of your hotel portfolio and divert those funds to Airbnb. Now, the question is, let's say we did want to go with that recommendation, where would we put it in the slide? I notice the only sentence we have here is Airbnb versus hotel bookings over time. And if you open a statistics textbook, it will tell you in the section on charts that the appropriate title for a chart is simply to repeat whatever the y-axis and the x-axis represent. So the y-axis represents Airbnb bookings and hotel bookings. The x-axis represents time, so we get the Airbnb versus hotel bookings over time. And I did titles like this for years and years. These titles are appropriate in the academic setting for a research paper. But in the business setting, we actually just want to get straight to the point. So I'm going to propose something slightly revolutionary. The title for this chart should be, please liquidate part of your hotel portfolio and divert those funds to Airbnb. Right? Get straight to the recommendation. And then the chart backs up that strategic recommendation. Okay, so I call these storytelling titles. And in the business setting, I'm always trying to add them to my charts. Now, before we adjust our title, we have to do something about the chart design, because just looking at it is making my generalized anxiety disorder flare up. So what are we going to do about the chart design? Any suggestions, no matter how small? Yeah, someone said lines. Yes. Yeah. Let's go to a line chart. Okay, good. And I notice also that there's excessive labels here, right? So let's go to a line and delete the excess labels. Okay. Anything else we want to do? Yeah, remove the gray background. A lot of DataViz packages include gray backgrounds by default, inexplicably, not mentioning any names, ggplot2. But yeah, let's get rid of that gray background. Okay, much cleaner. Yeah, get rid of the grid lines. Now, here's the thing: grid lines are actually really useful. Okay, so we got rid of the numerical labels, which is as precise as you can get. Then we got rid of we could get rid of the grid lines, but then we're kind of lacking precision a little bit. But sometimes that's okay, because sometimes your user just wants a general picture of what is the overall relationship So this is a design decision that you, as the data storyteller, have to make. You could get rid of the grid lines there. Anything else we want to do? Yeah, exactly. Too many decimal places on the Y, and the x-axis, I'm kind of reading it like this. Humans don't read 90-degree angled text very well. So I have rounded the y-axis and I've abbreviated the x-axis. I now give this chart a D+. So we started at a D-, now it's a D+. Now, let's do something about the legend. Any ideas what we can do with the legend? Yes, exactly. Put it next to the line. See, in Excel and ggplot2 and matplotlib and every single data viz package, they usually give you 4 options for legend placement: top, bottom, left, and right. And what they think is a good idea is to draw these little baby lines and then a word, and then you've got to kind of associate them at a distance. And this is really terrible from a UI UX standpoint. So in our endeavor to create a better legend, I'm going to consult 3 German psychologists. These 3 German psychologists are known as the Gestalt researchers. They are the fathers of what is now known as modern-day Gestalt therapy. Gestalt is a German word that means pattern, as I'm sure many people, there's probably some Germans here that could verify that. And so these 3 psychologists discovered some rules that govern the way humans perceive the world around us. They discovered that we perceive the world around us as a series of patterns. And we're going to look at some of these patterns. So the first Gestalt law is the Gestalt law of proximity. This law, well, before I introduce the law, let me just run a bit of an experiment. Looking at these dots over here, some of you will see columns and some of you will see rows. Hands up if you see columns instead of rows. Okay, thank you. Hands up if you see rows. Okay, thank you. A few hands, and it's totally fine. Sometimes some people do see the world differently. But most people here saw columns, and the Gestalt researchers were curious about this result. And they discovered that people see columns because the proximity of the dots on a column basis is much closer than the proximity on a row basis. Things that are close together are seen as being together. And it happens at very fast cognitive processing velocity. So think about how long it would take the average user to link this and this and this and this, and then compare that to the speed at which you saw columns there. You probably saw columns that probably felt almost instant. So we want to tap into this underlying psychology in our legend design. So of course, what we want to do is move the legend right next to the line, right? Why mainstream data viz packages don't do this, I don't know. If I just had 5 minutes in an elevator with the CEO of Tableau, like that's exactly what I'd be asking them to do. But anyway, they don't. Maybe they're here, I can talk to them. All right, so, okay, so that's a much better legend. We can actually do even better. So let me introduce another Gestalt law. Now I'm holding the proximity of the dots the same on a column basis and a row basis, and yet you all see columns or rows. Yeah, most of you will see columns here because things that are colored the same are seen as being together and grouped. And it happens again at very fast cognitive processing velocity. Okay, so we associate things that are colored the same. So of course, what we want to do here is combine Gestalt laws. I'm now using the Gestalt law of proximity, but let's combine that with the Gestalt law of similarity, thus forming an instant and powerful association between the label and the line. Okay? I now give this chart a C+. Let's improve it even more. Let's increase its size. It was kind of a bit too small, so now those at the back are probably having an easier time. Let's use a better color scheme. I'm using the actual colors of the Airbnb brand there. And let's think about labels. I might want to add a bit more precision, but most people approach labels with an all or nothing approach. when actually some labels are going to be more important. In a time series, the more recent labels are more important than the ones in the past. So why don't we actually just do selective labeling? When you actually have less labels, then they're more likely to actually be read. Okay, and now let's add our call to action at the top. Big, bold font, liquidate hotel investments and divert capital to Airbnb, and earning our salary as a data scientist, Airbnb bookings now outnumber hotel bookings 3-to-1, just adding a bit of analytics there. Okay, this is just one way of doing this. I'm by no means saying this is the only way. We could also have 2-layered area charts there, just to color that gap between Airbnb and hotels, just to draw attention to it. Okay, so we started with that, and we ended with that. Okay, so that's the audience. In summary, the very first thing I'm trying to do when I create a data story, at least in PowerPoint, is I'm trying to figure out this thing, and then I'm going to design my chart. Okay, so that's the audience. Let's move on. We're going to move on to the visuals now and chart selection. And this next example I got from a website, businessinsider.com. And I'm sure many of you have visited this website. Very popular website that looks at, mainly they look at what's going on in the tech industry, but they have evolved to be just a general media company now. And Business Insider has a section of their website called Chart of the Day. And I check Chart of the Day actually almost every day, because it's a good, reliable source of bad charts for my training courses. And one day, they came out with this chart here, and I got really excited, because I actually emailed my colleagues and I said, this is it. This is the bottom. Like, you can't get any worse than this. So this is real data. This is Apple's global revenues broken down by region. You'll also see, curiously, that retail is on there as well, treated as a geographic region. So I've actually talked to an ex-Apple employee about this. Apparently, sales from an Apple store used to be treated as a separate region. So if you bought an iPhone from the Apple store in Singapore, that would be counted in retail. But if you bought an iPhone, when you go to a telco in Singapore, then that would be included in rest of Asia Pacific. But they apparently changed that methodology midway through. That's why we see retail there, just to clear that up. I don't normally clear that up in this, but I know we're a room of data scientists, so I said I'd better do it here. So, all right, now, okay, so let's do this better. First things first, before we talk about chart selection, color, anything like that, first things first, what is the big takeaway? So we've got to say, who is our audience? Our audience are the readers of Business Insider. They're not executives. They just want a general, interesting story about what's going on at Apple. What is our big takeaway for the readers of Business Insider? Any suggestions? Yeah, the growth in China, yeah. I mean, there's multiple stories we can tease out here, but I think the China story is really the most interesting. And so, does the stacked bar chart do a good job of telling the China story, or is there a chart type that we might want to use instead? Any suggestions? Put what, sorry? Yeah, very interesting that you mentioned that, because it's very easy to follow the trend in the Americas, because the Americas has a solid baseline. China, however, is not sitting on a solid baseline, and hence its trend is hard to follow. Now, there's actually some research that backs this up. So let's choose the right chart based on some research. And I'm super glad no one said pie, because I go through this example a lot, and I get people who suggest that this could be a pie, and this could be a pie, and you effectively end up with a time series of 14 pies, and no one wants a time series of pies. All right, so let's draw on some research from William Cleveland and Robert McGill, two statisticians who were having this very discussion. They were trying to figure out, when do we use a line, when do we use a pie, when do we use bar charts? When do we use a stacked bar chart? And they came up with this ranking scale of how good humans are at certain perceptual tasks. Let's take a look at their experiment. The first experiment they did, they conducted an experiment on 51 human test subjects, and they drew a y-axis, just like what you can see here, and they labeled 2 points on this y-axis. And they asked the 51 human test subjects which dot is higher. And of course, that's easy. Humans are very good at deciding on what has higher magnitude there. But then they asked, what is the magnitude of the distance between the 2 dots? And they found that when comparing 2 positions on a common y-axis, humans are quite good at this task. Now, this is good news for those who like line charts, because a line chart is effectively a common axis with a series of points that have been just connected by a line. So line charts perform quite well based on the Cleveland and McGill scale. They decided to repeat the experiment. They said, what if we put the second dot on a lower axis, on a separate axis, and that axis will have a lower baseline? And they again asked the humans which dot is higher, and they again asked the humans what is the magnitude of the distance between them. And they found that accuracy, as you would expect, went down slightly compared to the previous experiment. But humans were still very good at deciding which was higher. They said, okay, what if we convert this dot into a length, and this dot into a length, like so? And they asked the humans which line is longer, and they asked the humans to assess the magnitude of the distance if they are told what the longer line represents. The actual numerical value of the longer line. And they found that when comparing lengths on a common baseline, humans are not as accurate as in the previous experiments, but they're still quite good. So this makes intuitive sense. Like for those of you who have brothers and sisters, when you were growing up, you probably compared your heights standing back to back on a solid baseline. Now, let's go to the next example. They said, well, what if we put the second line on a lower baseline? And let's ask the humans which line is longer, and please assess the magnitude of the distance between the two. And they found that humans were much less accurate under this experiment compared to the previous experiment. Okay, and this makes intuitive sense. I wouldn't compare my height to this gentleman here while I'm standing here and he's standing on the ground. No one does that. Okay, so this has implications for this chart. For the Americas, we're comparing lengths on a common baseline. For China, we are comparing lengths on a non-common baseline, and we struggle, okay, based on the research. So I want to go to a different chart type, okay? That chart type, well, I am always trying to use lines where possible, or regular bar charts on a common baseline, because the research states that they perform quite well. So let's go to a line. Okay, we have an absolutely disgusting line chart here, straight out of Excel. As bad as this chart is, wouldn't you agree that it is now easier to follow the trend in China? Okay, it should be slightly easier than it was under the stacked bar chart example. So we now end up with what is known in the data viz community as the spaghetti line chart problem. How do we deal with the spaghetti line chart problem? Well, one method is to, let's first of all get rid of all the clutter, and let's add our Gestalt labels to the lines. But it's still a bit tangled. There's still a fair bit of occlusion between the lines. Well, if we want to focus on China, let's just color China. Okay, now the focus is there. We've also added a storytelling title. Greater China is now Apple's second most important market. And we can choose to bring in the Americas into that story as well. So when I create my data stories, I will often gray everything out at the start, and then very intentionally deploy color based on what I want my audience to focus on. Okay, let us continue. Now, in the Cleveland and McGill scale, we stopped at comparing lengths on non-common baselines. But the scale goes a lot lower than that. And what Cleveland and McGill found was that humans don't do a good job at comparing areas. So let's put this to the test. with the most commonly used chart that compares areas, which is clearly the pie chart. Here I have a 5-segment pie chart. And we all know not to use 3D pies, but what about a 2D pie? So let's actually vote on which slice is largest here. Who votes for slice number 1? Any votes? Okay, slice number 2? Yeah, we've got a vote at the back, thank you. Slice number 3? Okay, handful of votes. Slice number 4? Okay, slice number 5? Who votes that they're all the same? Okay, so we've actually proven the vast ineffectiveness of the pie because we disagree. Someone said slice number 2, a bunch said 3, a whole bunch said 4, and then a whole bunch said they're all the same. Well, this is clearly an ineffective graphic because one of the whole point of a graph is, well, one of the main tasks of a graph is to allow you to ascertain relative magnitude. And clearly it's fooled a lot of people. So here's the actual data. Slice number 4 is the largest, and I haven't even told you the numbers. All I'm doing is converting into a bar, and now it's very clear what the highest is, and you can probably very accurately ascertain relative magnitude from highest to smallest now. Okay, so bars vastly outperform pie charts. I will still use a pie in limited situations. I will use pies if it's very important to imply summation to 100%. That's something a pie does quite well. It implies that this is the whole shebang, all of these slices, whereas the bar doesn't necessarily make that visual implication. But a little part of me dies inside every time I use them. Okay, so we saw that the pie didn't perform too well. Well, I'll come back to volumes in a moment. But this kind of brings me to a quote from Edward Tufte. Edward Tufte, obviously the godfather of modern data visualization theory, professor at Yale. He says the number one goal of any chart is to, above all else, show the data. That is the number one goal. And that's why we want to avoid charts like this with similarly sized slices, because it's not showing the data as well as it could, and in fact it fooled a whole bunch of people. Now, showing the data is not just about choosing the right chart type. It's often about removing all of the junk that our out-of-the-box data packages include. ggplot, matplotlib, Tableau, Power BI, Excel, all of these packages include junk on their charts that can be removed. Here we see a bar chart that is not showing the data as well as it could. It's got vertical grid lines that we do not need. It's got a blue background that we also do not need. And we can remove those elements and have a much cleaner chart display. Now, Edward Tufte had a term to describe these unnecessary elements in charts. He calls them chart junk. And it was his goal in life, and it is his goal in life, to rid the world of chart junk, one exploded 3D pie chart at a time. Now, what does a statistician do when they have a goal, when they want to do something, and they're angry? Edward Tufte invented a formula. And the idea was that this formula would rid the world of chart junk. Okay, the formula is, and many of you will have seen this before, but the data ink ratio is equal to, and this can be calculated for any chart. So you take your chart and you calculate how much ink is devoted to the data. That's the necessary ink. And you divide that by the total ink used to create the graph, where the total ink is equal to the data ink, that's the necessary ink, plus the chart junk ink. Now, any ideas how high can that formula go? What's the upper bound? For a chart that has no chart junk, that will be close to or equal to 1. So let us all strive for charts with data ink ratios closer to 1 than 0. Now, I will say this is just a heuristic, and it's just designed to be a way of thinking about good design. So please don't calculate the data ink ratio of your colleague's chart, and they might not take too kindly to that. Okay, now, how is the data ink ratio of this chart? Well, there's a whole bunch of junk ink on the sides here. Okay, a lot of ink we can remove. So aside from the poor data ink ratio, there's massive, massive perceptual problems with 3D. And I'm not going to spend too much time on 3D because I think I'm preaching to the converted here. But I still see 3D charts out in the wild. So let's just briefly cover this. Looking at item C and item A, let's figure out what's bigger out of those two. Who votes that C is bigger than A, based on your perception? Okay, a few votes. Who votes that C and A are the same size? Okay, a bunch of votes. Who votes that A is between 1 and 2 times bigger than C? Okay, thank you. And who votes that A is more than 2 times bigger than C? Okay, a few votes. All right. Here's the actual data. Item A is more than 2 times bigger than item C. And actually only 3 people in the room voted in that direction. Okay, so 3D charts are a supremely ineffective graphic, or you can view them as extremely effective if you want to make your 5% look a lot larger than it really is. So if you want to tell a lie, an exploded 3D pie is really the way to go. You just choose to, the number you want to make bigger, you orient that closer to the user, and then you increase the width of your pie chart, and then you explode that particular slice. Very effective for telling lies. Okay. So we've covered the Cleveland and McGill scale, and we found that areas and 3D don't do too well on that scale. Now, earlier I had introduced the Gestalt principle of similarity. And this principle stated that things that are colored the same are seen as being together. Now, we applied this to our legend earlier, but there's actually another use for the Gestalt principle of similarity. And the other use is with our combo charts. As data professionals, we love our combo charts because they allow us to relate 2 time series to each other. And I like combo charts because they visually imply to the user that the 2 things that you're measuring are quite different. What I don't like about combo charts is the amount of eye tracking the user has to do. So when I look at this chart, I look at head count here, I link that to the bars, then I look here at the wrong axis, then I look over here, then I look over here, then I look over here, then I look over here. And that's way too much eye tracking for the user. Okay, so of course what we want to do here is use the Gestalt principle of similarity to improve on the design here. So what we're going to do is color head count, the axis, the same color as the bar time series, and color the revenue axis the same color as the line time series. And that will allow us to delete our legend, like so. And now the user will immediately know which axis corresponds to which time series. So just another little use of the Gestalt principle of similarity there. Okay, now there's one more Gestalt law that I didn't cover earlier. We've covered proximity, we've covered similarity. There's actually a whole bunch of Gestalt laws. But another interesting Gestalt law is the Gestalt law of enclosure. And what this states is that, for example, if you look at these dots here, most of you will see those 5 dots as being together because they are enclosed by a box. Most of you will see these 5 dots as being together because they're enclosed by a translucent oval. So things that are enclosed are seen as being together and separate from the rest. Now, this is actually really useful for our scatter plots because scatter plots encode an incredible amount of data. And often what we want to do is simplify it for our user. So I found this data visualization on Twitter. And the tweet that went along with it said, "People say data analysis is boring, but you can calculate the exact moment that Robert De Niro stopped caring." And we've got this beautiful upper enclosure here to signify the good years of Robert De Niro, suddenly plunging into the red enclosure down here. And we've transformed a pretty dry scatter plot into something that the whole Twitter sphere was able to understand because this went viral. Now, I do want to say though that with your enclosures, different enclosures tell different stories. This enclosure tells the story that Robert De Niro suddenly got bad. But what if your friend, for example, said, well, actually, that's not true. Robert De Niro has always been getting bad in a linear fashion. Well, then you could use this enclosure, right? So the power is with you guys as the data storytellers. Do choose enclosures that show the data and try to capture the actual trend or pattern that you can see. Okay. Let's get into the last key to data storytelling that I'll cover in this session. That's the narrative. I want to give a bit of context before I open the next example. So I'm in a relationship right now, and you get to a point in your relationship, I'm sure many of you can empathize with this. You get to a point in your relationship where your partner asks you about your previous partners. Has that happened to anyone here? Okay, so you get to that point, and I said to myself, what sort of data scientist would I be if I didn't use a chart to answer her question? So I came up with a cascade chart. So what we have here is how intense my past relationships have been compared to the age that I had the relationship and compared to the duration of the relationship. Cascade charts are basically just like a special bar chart where the width of the bar is actually meaningful. Now, what did I do first? I grayed everything out and decided where to deploy color strategically. The big problem with this chart, though, is it's not telling a story. That title, Intensity of Relationship versus Age, adds absolutely zero value to this chart. Because if you look at the y-axis label, Intensity of Relationship, look at the x-axis label, Age, well, it's clear that's what we're looking at. So I don't need to say it again. That's actually redundant text. So in my title, I want to summarize the story. And how I summarize the story is going to be different depending on who my audience is. If I'm presenting to my buddies in the gym, I'm going to have a very different story to when I'm presenting to my partner. So what is the story here? I mean, we can talk about trends. There's a general upward trend here. I seem to be getting into more intense relationships as time goes on. These bars are getting thicker and fatter over time, so I'm kind of getting better at this. The relationships are getting longer. I obviously won't use the words thicker and fatter in my storytelling title. And I could talk about outliers. You know, we see that Brazil is certainly an outlier, and my exam period was a negative outlier, right? So what I ended up doing was I said, well, my relationships have increased in intensity and length over time, and I no longer speak to Isadora in Brazil, just to provide a bit of reassurance there. Now, how did I link this insight to this part of the chart? See, when I was a junior data scientist, what I used to do is I would put my insight here in a box. I'd say, I no longer speak to Isadora, and I'd connect that box to the part of the chart it refers to using a connector line. And every time you do this, Edward Tufte cries, right? Because you're adding chart junk to your chart. So what you want to do is create linkages in your chart using the Gestalt principles of proximity and similarity, because then you're not adding additional ink to your chart. And it results in a cleaner look. These little tweaks are really important, especially with dashboards, where you're presenting so much information in one view. Okay. Now, further on the topic of the narrative, I recently came across this slide here. I'm actually half Filipino, and I do a lot of training in Manila. And someone sent me this slide. So this is actual data, whereas most national statistics offices are looking at inflation and unemployment. In the Philippines, they're looking at the percentage of people who've fallen in love with more than one person. This is actual data. And I said to myself, well, this slide is just far more busy than it really needs to be. So I went to work and I said, well, I can use the Gestalt principles of proximity and similarity on the legend, and we don't need 3D. And then I stopped myself and I said, hang on, when you've got less than 4 numbers, sometimes it's just better to say it in what we call in the data viz community an impact statement. So an impact statement is just a sentence that it contains the same information that the chart had contained, but just layers it in a sentence, and you choose a nice high-res image to go on the back. And when you've got one of those those monster PowerPoint decks that are just full of tables and charts, this can work well for a really important metric in your presentation. Obviously, you don't do it for every metric, just when there's a big headline number that you want to highlight. Okay, last example. Here we have a terrible chart of Apple, Samsung, and Huawei's sales over time. This is real data. And I wish I had more up-to-date data because Huawei actually overtook Apple just about a month ago. Now, has anyone had a colleague say to them, get it all on one slide? Yeah, a few nods around the room. Okay, I'm happy for those of you who have never suffered from that. And look, sometimes getting it all on one slide makes a lot of sense. Sometimes the person you're presenting to is very time poor, and sometimes the data you're presenting is not that complex, and you can compress it onto one slide. But other times our data is complex enough that getting it all onto one slide is sort of like trying to get Harry Potter onto one slide. You're going to miss out on certain useful pieces of information. And I'd say this is an example of one of those data sets, because a lot happened here. We had the release of the world's first smartphone ever, the original iPhone there. That was followed up by the iPhone 3G here. We see the rise of Samsung on the power of the Galaxy S2 and the S3. We see that Apple's sales are really spiky because people really wait for the new releases with Apple. Whereas with Samsung, people do wait for new releases, but Samsung has a really diversified product offering. They're always having new releases, so they have a much smoother time series. We see that Huawei sales are kind of spiky. They kind of have a seasonal spike. And if you dive into the data, you'll see that they spike every Chinese New Year. Here we see Samsung sales tapering off after the Galaxy Note 7 problem. Right, so there's all sorts of interesting tidbits in this data. And so one way of telling the story, rather than annotating the chart all over the place with insights and connector lines and things like this, what I like to do is build out the story in a staged manner. So I gray out everything and say, okay, Steve Jobs introduced the world's first smartphone, the iPhone, on June 29, 2007. And I'm just coloring the life cycle of that original iPhone. That was followed up by the successor to the original iPhone, the iPhone 3G, released on July 11, 2008, and it was a sales success. And we can just keep the story going. Samsung rapidly overtook Apple as the #1 manufacturer, driven by the strong-selling Galaxy S2, and Apple tried to catch up with the iPhone 5 and 5S. And so on and so forth. And, you know, this is, obviously you don't do this in a dashboard, right? This is for your actual presented presentation. So you don't lose your audience at any stage. Okay, so in this short session, we've covered the audience. That's the first most important key. Who are they? What do they need to know? What I didn't mention before is this is where we also have to decide very early on what media is going to be best. Is it going to be a PowerPoint deck? Is it going to be an interactive dashboard? Is it going to be a D3 visualization or an infographic? So I've got to make that decision. Then source the right data and calculate appropriate metrics. Then select the right charts, ideally mindful of the Cleveland and McGill scale. Then design them well and layer engaging narrative on top. Those are the 4 keys to data storytelling. Thank you very much. Now, I think we have time for some questions. Yeah? Okay. Yeah, so let's, I welcome some questions.
So you're saying you have really an eye for graphics, and when there's something wrong with the graphics, why is your Venn diagram not overlapping?
Yeah, good point, actually. Yeah, it's true. So the question was, I say I have an eye for graphs, And if so, why is my Venn diagram not overlapping? It's a very good question. I actually have an interesting answer to this. So we tried to make it overlapping, and when you make it overlapping, it looks extremely unaesthetic. So, yeah, but good point. Yes? Yeah, so my incredibly dirty secret is that whilst I am a ggplot2 user, and I've recently, I'll repeat the question because this is being recorded. So the question was, how did I create the charts in this presentation? And I was just saying, my dirty secret is that whilst I am a ggplot2 user and recently shifted over to ggviz, all of these charts were made in Excel, every single one. And the reason is actually that's where most of our clients are playing when we deliver these trainings. So yeah, that's right. Yeah. So for example, like for this part, welcome to hell, right? You've got to click on the chart once and then click it again to select an individual point and then recolor that individual point, right? So I actually had to take some annual leave before I created that one. Any other questions? Yes. Yeah.
Do you have any tips, suggestions, whatever, how to go for that?
Yeah, so I've thought about this in detail. Really what I've come down to is to create beautiful charts quickly. It's just a matter of practice. It's just a matter of just creating lots of charts. Then you're speeding up your process because you'll have code snippets that you can kind of draw on, and it's just, for example, it does take a while in Excel, but the more you do it, you just get faster. In Excel, macros do help, and we've designed some macros that kind of would take you from there to that in a click. But yeah, in ggplot2, like in Python and R, it's gonna, you're gonna have to just be a code ninja, basically. Yeah, thanks. Any more? Yes? Yeah, what are the graphs that...
What are the news feeds or any suggestions that you normally receive on a daily basis that you say, well, that's a good one, that's a recommended one?
You mean...
So when you subscribe to a news feed, this is a Guardian, for example.
Oh, okay. Like how do I decide if a chart is good?
So which one's the source that you recommend to us that you normally see?
Oh, sources where I see great charts. Yeah, so the question is, where do I continuously see great charts? There's a Reddit subreddit called Data is Beautiful, which is, well, it's human-driven on a voting basis. So the better charts do make their way to the top, and there's a lot of statisticians and data scientists on there. So it's usually well-designed charts that make their way to the top. The Guardian is generally pretty good. The New York Times has produced some stunning interactive visuals as well. Although the designers at these publications often butt heads with the conservative kind of let's always use optimal design people. So for example, Stephen Few, who's a thought leader in this space, he often would criticize charts from the New York Times and the Guardian for being just eye candy graphs. And they do often choose a chart type. They might choose a sunburst chart when they could just use a series of bar charts just because it's visually stunning. And Stephen Few would often criticize them, but Amanda Cox, the head of information graphics at the New York Times, she said, well, everything could be a bar chart, but that's a world without joy. So there's this kind of balance. We have to balance our need for aesthetic beauty with our need to show the data, Edward Tufte's whole thing. I will often go further to one side or the other depending on the client and whether it's okay to lie a little bit with the data. Yeah, thank you for the question. Is there time for another one? Yeah. Okay, yep.
Would you, on your last slide,
Yeah.
storytelling graph, would you do it live in the presentation or would you pre-record a video different stages and have a voiceover as the stage is the same.
Yeah, if I was doing it for a live presentation, I'd want it on-click actions to stage through, because I never know when my audience is going to ask a question. Yeah. Was there a question there?
What do you do if you know that there is some colorblind people?
Yeah, great question. So yeah, what the question is, what do I do if I know that there's colorblind users in my audience? And actually, statistically, there are colorblind users here today. 1 in 20 males suffer from protanopia or deuteranopia. The particular colors that cause problems for these people are red and green, or green and orange. So going right back here, so default Excel legends are horrendous for people who suffer from color blindness, because they rely completely on color to differentiate which label, which legend goes with which line. So when you use the Gestalt principle of proximity, you totally solve that issue. So yeah, for colorblind users, at least for line charts, and actually this does apply to your bar charts as well. If you have a clustered bar chart or a stacked bar chart, you can apply the Gestalt principle of proximity also to those charts as well. So yeah, that's my first line of defense for making my charts more accessible to those users. Any more questions? Yes? Yeah. So the question is, what would be my recommendation for producing dashboards with Tableau? And what we sort of covered in this, in that last Apple Huawei time series example, was a staged PowerPoint-based data story. And so that's a chronological data story flow. It's a beginning, a middle, and an end. In Tableau and Power BI and ClickView, it's now a spatial story flow. It's more about visually where do things go, visually how do we assign importance based on spatial positioning. So guidelines there, I want my most important metrics across the top. Tableau did some interesting eye tracking studies in this area and found that people generally consume dashboards in a Z-shaped pattern. They read from top left to top right first, then move to the bottom left, then move to the bottom right. There are exceptions. Some people read them in completely the opposite way, but that's the aggregated results that they found. So yeah, impact metrics across the top, most important metrics in the top left, or most important graph somewhere in the top left. And the other thing I see people doing wrong, especially for business dashboards, is not using the right combination of metrics. So they might look at what is our profit today, and that's it. But often the user is interested in, okay, what is our profit today? What is our profit relative to target? How has our profit been trending? And so it's often a good combination of metrics that the user wants, and yeah, often people don't capture the right combination. Thanks. Okay, yes, question?
When is it better to use Tableau as opposed to Python for visualization?
Yeah, great question. So the question is, when is it appropriate to use Tableau instead of Python for data viz? And for me, I'm going to answer this from the business setting. If you're an individual user, I would just say, figure out the type of data stories you want to do and experiment with both tools for 3 weeks and see which one you want to use. But in the business setting, it's a different consideration, because in this situation, we often will have a team producing the business dashboards or producing the reports. And it can take longer to skill people up in data viz in Python, especially interactive data viz, compared to Tableau. So for many businesses, it makes more sense to go with Tableau and Power BI, because even non-technical people can be skilled up relatively quickly in these tools, because it's a drag and drop, point and click GUI environment. And let's face it, the job market for data scientists is hot. So if you've got a gun Python data viz developer, chances are they're only going to be with you for like 12 months or so until they get snapped up by Uber or something. So we often would recommend going for Power BI or Tableau in the business setting for enterprise data viz. Yeah. Okay. Time for more? Yeah. One more? Yep. Last question.
Do you have practice in implementing some visualization based on graph databases with your clients?
Yeah. Implementing visualizations based on, sorry?
Based on graph databases like Neo4j?
Oh, based on a graph database? No, I haven't done any of that, no. Okay, so yeah, thank you all for being such an engaging group. I really appreciate it. Yeah.